Hey guys, I'm back to talk about another AP Physics 1 free response question, and this time I'll be talking about 2015's question 1. So for this question, we're given that two blocks are hanging from a pulley system that are connecting them to each other. And for question 1, we're asked to draw the free body diagrams for each of these two blocks. So for block 1, we'll expect that there's some gravitational force equal to m1g and a tension force, just T. And the tension force should be greater than the gravitational force for block 1. Similarly, for block 2, there will be a tension force. However, this time, the gravitational force for block 2 will be much greater than the tension force. And now for part B, we have to derive the magnitude of the acceleration of block 2. So we'll solve this with a system of equations where we use the net force, or the F equals ma equation, for both of the blocks. So for block 1, that would look like tension minus m1g is equal to m1a. And for block 2, it would look something like m2g minus tension is equal to m2a. Yeah, so once we solve for tension and plug it into the bottom equation, we get something like this: m2g minus m1g is equal minus m1a is equal to m2a. Now if we solve this for acceleration, we'll get something like this: m2 minus m1 times g over m2 plus m1 is equal to a. And that's the acceleration of the system, which is also the acceleration of block 2. Now for part C, a third block is added in between blocks 1 and block 2 on the table, but it has no friction. So this really wouldn't change the forces acting on the system too much since there's no friction, but it would increase the mass of the system. So instead of just the m2 and m1 in the denominator, we would also have an m3. So it would look something like this: a is equal to m2 minus m1 times g over m1 plus m2 plus m3. And since we're adding something to the denominator, we'll expect that acceleration will go down. Yeah, so this was a quick one. I hope you guys enjoyed and learned something, and I'll see you in the next one.